All right, so I have to hurry because it's starting to rain, but I want to give an update on this compliant truck design here. I meant to make an update for this, but I ran into some execution problems. First off, I didn't leave enough clearance for it not to get wheel bite, so it'll bite on the base plate and on the deck. And so I'll have to refigure that out. And also the way I sliced it and tried to make it work, it didn't work. So I've got to figure out a better way to print it. But I am trying to go with a 4-limb spring, so that way if one breaks, you won't be SOL. But I think I could get away with just a 3 spring. I think that would work fine. But since I can't show you that, I started work on a different project, and this is a strange channel truck concept. And this was originally designed with e-skate in mind, so the idea was a big motor in the middle and how to make a truck out of that. The idea was to use, a bushing seat, and you could use a pivot cup on the other side, but I thought I could use this groove-shaped channel thing, and it's actually got kind of a other planet cam thing going on. There's one weird fluke about it, in that, well, there's this. That's not very good, but I can do that and show you better detail. It's got this cam profile here, and it's swept around like that, and so the truck will actually follow that profile and turn, except it has to be held in by the weight of the rider. So if you're not standing on the board and holding it in, it can actually just flip around. But I think it will work okay if I'm standing on it. To execute this better, I'll have to figure out a better way to retain the hanger. But let's take a look at it and take it down the hill. So it mostly works with weight, but it's kind of quirky. Mostly it's not doing a whole lot, which is preferable to it being all crazy. But you can see if it's unweighted, it's kind of just whatever. But I feel pretty safe riding it because it's trailing, so kind of the worst case scenario is it's going to trail behind you and not do anything ridiculous. But you can see if I kind of skew it a little bit to the side and we put your weight on it, it does snap back and into the groove and straighten out again. So there is some influence, but it's not, concrete control for sure. And then the other thing that's kind of a concern is how easily it's getting wheel bite, even though I've got these big cutouts. So anyway, here we go. We're gonna take it down the hill, and hopefully I'll survive. It's pretty trippy feeling. I'm concerned that noise is one of the wheels coming loose. All right, so things were already sketchy because I was holding this board in one hand and the camera in the other. So I didn't feel comfortable carving too much because of that. Also because of the wheel bite. I mean, that was sketching me out. If, you know, the short wheelbase too, if it catches, it's going to throw me off the front, and with stuff in my hands, just not very good. But then when it started rattling, that was this going on. And then when I picked it up, that nut fell off. So yeah, that was that one run was plenty, I feel like. So the conclusion is that yeah, it definitely needs more rigid confinement that does not rely on any forces holding it in position. On a couple places there, I felt it doing a little bit of a ripstick motion where it would kind of just swing, and it was actually like once. But I could tell that the G-force of me on the deck, like this, was causing it to turn like that, even with the deck flat. So it was the forces pushing it sideways was overcoming the resistance put on by your weight, which is basically that's basically exactly how a ripstick works. So I made a ripstick here. Made a ripstick truck. But yeah, so better confinement, and that's not impossible to do. So I'll just have to mess around with the geometry. I would have changed things and redesigned it before, but I really wanted to see how this would ride in the first place. So this isn't the sketchiest thing I've ridden, but this is the sketchiest thing I've ridden with my hands full and without a helmet on. So so I'll redesign this, and I'm really eager to try it again with a better design. So I also want to talk pretty quickly about this piece here. So this is 3D printed, and this is just glued together with epoxy, but I didn't want to bust out the bushing seat, because that's just it's less than it's like, was it 2.5 millimeters thick. That's really thin for something that's holding back the force of a bushing. I'm sure some of you have seen aluminum bushing seats that have busted out. So this is pretty cool. What I actually did is I've got a sheet of carbon fiber sandwiched in the middle there when I glued it all together. So it's actually got carbon fiber reinforcement going all the way down. And this thing was still way too flexible. So if I put it on here and tighten it down, it was actually twisting the whole bushing seat. But I was still pretty confident that it would not just break outright very easily. So that's a pretty sweet idea, I think. If you're going to 3D print any sort of conventional truck with a bushing seat, before I was, you know, I've never attempted to do a 3D printed bushing seat before, because just the strength is just not there. But I think with this idea, this strategy, I think 3D printing a truck becomes a lot more viable. Of course, you don't really have to worry about a lot of the other strength of the truck if you've got a nice solid axle. These are 10 millimeter threaded rods, but if you have a 8 millimeter hardened bolt, there's a ton of strength that can hold your entire hanger together. So it's the only things you really have to worry about are the bushing seat and the pivot. So there we go. There's the crazy truck design. Longboard technology, over and out.